Okay, guys, thanks for being here. We are here with Natasha Uprit from Unity, and I've had a chance to chat with her a little bit before we got started. She volunteers with Career Village, coaching young students around the world about data engineering to help them just upskill and with principles so they can understand how to pursue careers in data. She loves dancing. She teaches Zumba classes, Zumba Bollywood dance classes. And she joined Unity because she believes in the future of gaming, AI, um, and how the metaverse will play a role in changing the world for years to come. And she's already one of my favorite people. And so, with that, I will give Natasha you can take the floor.
Awesome. Thank you so much, Ro. That was an excellent introduction. Thank you for that. Appreciate it. And hello, everyone. Thank you for joining me today. I'm really, really excited to be here. First of all, thanks to Data Engineering and Machine Learning Summit for inviting me to speak and giving an opportunity to speak with you all and share my experiences. I'm going to start sharing my screen so that you guys can see. And one second here. Okay. Ro, can you see my screen?
You might want to turn on the slideshow. Perfect. Yep, you're great.
Awesome. Thank you. So let's get started. In today's session, we are going to talk about some strategies for success with next-gen data stack. And before that, a little bit about me. I have good data engineering experience, been in the industry for more than 18 years. And the basis for my data engineering background started in a company called Greenplum. Not sure if many of you are familiar with that, but it is a massive parallel processing database company. That's where I learned a great deal about databases. And I joined them. It was an 18 people company. I left. It got acquired by EMC, and it was about an 800 people company. So very early on in the start of my career, I was doing a lot of startups. So from there, I moved on to another startup called Burst. It's BI in cloud, a natural progression from learning the databases to now the analytics side of the data. That company also got acquired by Infer. And from there, I joined my husband's startup. He was building a company on data integration space, data preparation phase, and it was built on top of Hadoop. This is an era of big data implementation where big data was like really booming up. And so that's when I joined him. And while he was building the product, my major role was to be on the road, do a lot of sales engineering, do a lot of teaching to all these different organizations on the principles of data engineering. And the product that my husband was building is, think of it as like ETL in cloud, but on top of big data implementation. So I did a lot of big data implementations for enterprise companies like Disney, Nike, Visa, and it was interesting to get an experience of what does it really take to sell a startup product to the enterprise companies. So in my startup journey, I learned that, like, what does it take to build a startup, raise funds to get it acquired. The company got acquired by Dell. And then I was like, okay, I think I'm done with my startup journey. I should now get a taste of enterprise companies. And that's when I moved on to Atlassian and companies like Atlassian and Unity, where I grew the organization, data engineering organizations, and managed them globally. And interesting learning during Atlassian was, I realized no matter what the size of the team, but even if it is like a 10 people team or a 50 people team, still 44% of the time data engineers are spending on managing data infrastructure, data pipelines, and whatnot. And every enterprise has the same story. So that is a key takeaway from Atlassian. I'll talk a little bit more about the use case studies on Atlassian and what challenges we faced and how we solved them in the next few slides. And then I joined Unity. And here I was managing the Unity ads organization, data engineering teams. It's a wonderful experience too. But at Unity, again, as in all the enterprises, a lot of data engineering challenges, data duplication, there is no standardization of data pipelines, and that leads to inconsistent reporting of your metric. But a key learning at Unity was, since I was working very closely on ads organization, data played a very key role on providing input to machine learning models. And why is that? Because these models, ML models, is going to help bring more business to your organization, more growth to your organization. So it's an interesting learning. Like, you can see data from two perspectives. First, how are you going to actually use the data and data engineering principles to report on how your business is performing, which is the analytics side of the data. But at the same time, how can you use the power of the data to bring more business to your organization, to bring more revenue to your organization? So that was the key learning at Unity. I'm happy to share that as well in the next few slides. And learning from all these experiences, it was quite fascinating journey. And I'm happy to go forward and share the agenda now with you guys. We'll talk about data stack evolution, how in my career, in my experience, I have seen the data stack evolving. What are the challenges I faced as enterprise data leader? What are the challenges my teams faced as data engineers? What are the challenges of modern data stack? And what are some quite possible solutions that we implemented at Atlassian and Unity? And then how AI is taking up the space. The combination of data engineering plus AI, I see there are tons and tons of great opportunities, but it's far away from enterprises today. So how can we as enterprise leaders bring that power in? I'm going to talk a little bit about that. And then what is the value add of applying data plus AI principles together to data engineers? So that's my agenda. Let's get into the data stack evolution. So here I'm explaining a timeline of how I have seen data stack evolve over the years. As you all know, in 1990s or even in the 2000 phase, there were the world of like informatica, microstrategy, business objects, Cognos and whatnot, right? Like very, very IT driven. The data product companies were mainly selling it to the IT teams in those big companies. Then slowly came the evolution of MPP databases, which is the companies like Greenplum, Natiza. These were like massive parallel processing databases. And that was, a good paradigm and a move and a shift to big data, and where big data and Hadoop became really, really popular in 2010, between 2010 and 2015. And at the same time, cloud offerings were coming to become very, very, very popular. So the combination of Hadoop and cloud offerings and made data engineering shift natural. Progression of data engineer roles becomes like software engineer roles, and very slowly I started to see the shift that open source technologies are coming in when we talk about modern data stack. And with open source technologies and open source tools which are available out there in the market, like Airflow, Airbyte, DBT, all these are like open source, and they are more heavily engineering driven. A lot of enterprise companies are adapting these open source technologies to then build something proprietary on top of it to derive quickly their business insights. So the engineering mindset is shifting from IT to more of software engineers. I see there is a very fine line between a software engineering role and a data engineering role. So you could be working as a data engineer, but you might very well have software engineering principles, and you could still be a very good rockstar data engineer. So that shift I have personally seen in my career, and I've seen the data stack is evolving. And the key findings for me is like why data stack evolution is happening is, again, the engineering mindset is coming in the data roles. And if what I have seen in enterprises like Unity, Disney, Nike, all these big companies, that there is a crazy procurement cycle. Even if, and as an enterprise leader, I want to onboard a startup company or any tool like Calibra from governance perspective, Alation, Fivetran, whatnot, right? they always get stuck in the procurement cycle. And the period is anywhere between 3 to 6 months. It can vary for different enterprise organizations. But the challenges for data engineering leader is like, oh, by the time I can onboard you, you clear the procurement for me, I have budget for you, but you're stuck in procurement. I'm not able to use your software. My requirements have changed. My engineers have evolved in the from the legacy tech stack to modern data stack, and those are the kind of challenges we faced. So I saw the evolution naturally progressed towards, oh, there's a lot of open source tools out there, and enterprise data engineers are adapting to them. I saw the shift from Atlassian days. Hey, can I just download this open source software on my laptop and start building my data pipelines really quickly? How fast? I don't have to go through the procurement cycle. It doesn't come with big bills. There is no crazy sales cycle. So open source became very convenient option for data engineers to adapt to. And again, it's cloud native tooling is everywhere. Everybody wants to be agile. A lot of managed services that Google Cloud, Amazon, all these different companies are providing has made life a lot easier, right? So that's the natural progression for data stack evolution. And not just that, like right now we are seeing exponential growth in the volume of the data. And with AI, it's just going to explode. Yeah. So after seeing this data stack evolution, let's talk about like how do I see a data engineer or data leaders spend their life, a day in a life, right, of a data leader. What do I typically do? What does my day-to-day look like as an enterprise leader? And what challenges do I face? So what I did in Atlassian and Unity both is like, we conducted a lot of interviews. My job is to meet with my stakeholders who are sitting in marketing, finance team, business teams, and whatnot, and try and understand what challenges, what data challenges that these customers of mine within an organization have. So I'm going to share some of the key challenges that I personally faced. The challenge number one for them when I interviewed all these stakeholders is like, we don't have any data visibility. Data producers, they have no visibility into the downstream usage of the data. Who are these data producers? These are product teams, engineering teams who are working on a product, say, for example, Unity Ads platform. It's a product engineering team that's generating the data for Unity Ads platform, but their job is to just do the event instrumentation and make sure that the downstream teams are going to consume it in whichever way they want to consume it. But a lot happens between data producers and data consumers. How the data is adapted, data engineering comes in between. They sit in between these two big organizations, and they have the hardest job of understanding the data the way it is coming, transforming and conforming it to the business definition model so the consumers can use it. But there is no visibility between the data producers and the consumers. Things often change, often fail. Data engineering, since it is sitting in the between these two organizations, often becomes a bottleneck. And if the changes are happening, schema level changes are happening, no one really understands who made the change, why that change has happened, and what is the downstream impact for it. So a lot of stakeholders are like, I don't even know to start with. Where is my data? I couldn't even find it. From where is it coming from? Right? The challenge number two I saw and heard a lot about is the evolution of data pipelines. Data changes. There are complex filters that data engineering team, by understanding the business logic, they are applying those constant changes to the data pipeline. Data model is evolving constantly. It's like an iterative process. Why does data model evolve? Because business requirements have changed, or perhaps a new attribute got added from business perspective, and we need to incorporate that attribute into our data pipelines. So a lot of times this results into spaghetti SQL code, which you all are aware about, and it is very painful to parse that. It creates a lot of uncertainty in the data. data quality issue becomes like a biggest challenge for the industries, so for the enterprise companies as well as for data engineering leaders. Then the third problem I heard from my stakeholders is like ownership. Who owns what aspect of the data? There are always analytics organizations, there's always data engineering organizations, and then there are product teams who sit in the business or in the business teams. Now, the data engineering teams are in some companies are centralized, like in Atlassian, we had a very centralized way of reporting data, and one central data team sending data needs to the vertical organizations like marketing, finance, or whatnot. But in Unity, we were very decentralized. So if the organization, data engineering organizations are quite decentralized, then which team owns what kind of data? Product teams want to act in an agile way. They end up hiring bunch of their own data engineers because they are domain level experts. They understand ads ecosystem, right? So now they can play a role of an analyst also, and they can play a role of an engineer as well, right? So that creates a confusion. Does the analyst own the data pipeline? Can I do whatever I want sitting in a business team, or shall I rely on a data engineer to do that change for me? So this is a huge battle, if more not necessarily a right word, but it often happens in the enterprise organization where there's no clarity of ownership of the data pipelines, which leads to blame games and something broke, and then nobody raises the hand to fix it. Okay, so those are some very close challenges that I felt very common across Atlassian, even in my startup journey. Doesn't really matter which domain you're working in. I have worked in financial domains, medical domains. I've sold the software to entertainment, banking customers, and whatnot. So domain doesn't really matter. Data engineering challenges are quite similar across different companies or different enterprises or organizations. Now let's see from the lens of a data engineer, what does a data engineer go through on a day-to-day basis? So a day in the life of a data engineer, I expect my data engineers to learn the business, build the data pipelines based on how they have learned the business, monitor the data pipelines, and then scale it with the production grade data that we have. And I'm talking about terabytes of data, petabytes of data, right? It's an event stream data which is coming from Unity ad systems, or all the different producers of the data are consuming tons and tons of data on a daily basis. So our job from the data engineering perspective is to learn the business domain, build the pipelines, monitor, and scale it. But what is the reality? Everywhere I have seen data engineers struggle with competing priorities. I'm the one, and I take that, telling my data engineers, oh, sorry, I told you a few weeks ago, you got to work on this, but suddenly the CFO has reached out to me, and now we have to work on the financial data pipeline. Wait a minute, Natasha. I thought we talked about working on a standardization. We talked about how can we make the data lake house more standard and apply certain data engineering principles so we can avoid data duplication or whatnot. But now you're asking me to work on financial pipeline? Oh yeah, because we have to report certain numbers to Wall Street. So yeah, let's stop everything and start working there. Happens quite often. And then the other challenge that data engineers go through is every enterprise company they work with, every enterprise has a legacy data stack. It's a combination of, like I have seen Redshift. I mean, I don't know if I should call Redshift a legacy still, but it's quite legacy for me. And then there is a lot of like old way of doing things in enterprises. Then data engineers, they're like, how do I modernize this data stack, Natasha? Like, there's so much open source tools which are available out in the market. I could just install those tools even on my local machine, and I could be super productive. But I don't get to do that here very easily. How can I start looking into it? And I hear them, I hear you, right, data engineers. Let's go and look into what open source technologies do we have. Let's see what does the modern data stack looks like. And then suddenly a data engineer is bombarded with this challenge. There are too many tools out there in modern data stack. If I have to just look into a data discovery tool, data observability tool, quality tool, there are tons and tons of open source companies which are built just who are good in data quality, like Soda Core, right? DBT for transformations, for building your data models. You can use DBT on BigQuery, you can use DBT on Snowflake. There are tons and tons of options which are available out there when it comes to the open source world. But there is one problem. There is no out of the box tool integration. A job of a data engineer is to build an end to end data pipeline. I should have an ability to ingest the data from via APIs from different applications like Salesforce, CRM tools, or whatnot. I should have an ability to quickly transform the data using DBT or whatever transformation choice of tool I have, and then quickly put the quality checks embedded within the pipeline, not outside of the pipeline, within the pipeline, and then make sure I could quickly derive some insights out of it. But there is no open out of the box tool integration in modern data stack today, like Airflow, DBT, Soda Core. You name all this modern data stack open source tools, but there is no company has defined an easy integration. So engineers often try to build that integration themselves in-house. Oh, Natasha, give me a few weeks. I can figure out how DBT talks to Airflow. I could create that integration, and then it would become a lot easier for all my other data engineers and for my different teams. But it's a challenge today if we don't do that, because then building end-to-end data pipeline becomes complicated. So the good thing from my lens as an enterprise data leader is, okay, hey, dear data engineer, if you're saying that you could take few weeks of time to build that integration for me, and it can avoid me paying big checks to these companies, okay, I'm fine. What is the dollar we are saving here? Can we say no to Calibra? Can we say no to Atlassian? Can we say no to Fivetran? And can we use the power of open source technology to build integrations internally, and then I can save big dollars here? So if my data engineers come to me and say, yes, that's a possibility, that's a huge win as a data engineering leader, as a data engineering organization. So we tried variants of that. Let's move on. Another problem that a data engineer goes through, it's a persistent data engineering problem. You all have seen it. Upstream changes has happened, pipeline breaks, all the dependent pipelines downstreams are going to break. A typical day in a life of a data engineer, I'm going to debug where the issue has happened. Now I'm going to locate the upstream change where the change happened, blame game starts, and then we fix the pipeline and move on. This, you guys are very well aware, it happens in every single company. And there is a lot of things data engineers are dependent on, because there are legacy data pipelines which are still, you'll be surprised that in big companies like Atlassian and Unity, still a lot of legacy data pipelines are written, and businesses rely on those pipelines. They are crazily equally important. Yeah, and that's a fact. Okay, so we talked a lot about the problems, and I'll quickly go over the solution that we tried to apply over Atlassian as well as Unity, and how it kind of like helped us. We weren't able to create like a full-blown solution, but it still helped us fix a lot of the problems that kind of like I talked about. And maybe that's helpful to you all as well. So let's see what are the possible solutions with next-gen data stack. So we talked about the uneasy problems. There are too many tools out there. There are no tool integrations. Hence, it results in metric inconsistency. There is no easy documentation of data pipelines. No change management is clearly tracked. There is no built-in data ops capability. And hence, things are slow to insights. So what are the solutions? We tried to build a single command line interface integrated with open source technologies like Airflow, DBT, and Superset. And you can use Soda because it's just a Python library, and it will help you do Soda integration to embed quality checks within your pipeline too. And not just that, if you want to avoid data duplication of pipelines like people, analyst teams, and so many other different decentralized data engineering organizations, what do they do in order to get their day-to-day fast? They quickly copy paste a previously written pipeline, and they start building something on top of it. They don't want to take a headache of writing the entire data pipeline and code again. What it leads to data duplication, high storage cost, compute cost, lot of airflow work jobs are running. They're not even being used. I got my job done today, and now somebody's even forgot to stop that pipeline. I need to pay the heavy cost for it because it's nobody even knows that that pipeline is running. So we thought of implementing medallion architecture. If you want to understand more or detailed technical knowledge about medallion architecture, happy to talk about it. But it's the beauty of like providing standardization in your lakehouse. What it does, it gives a structure to the data which is landing in the lakehouse. You have three layers. You have bronze layer, where all the raw data lands into your lakehouse, can sit in the bronze layer. From there, you want to apply some pre-processing checks like quality checks. There are nulls in the data. There is like date column field, which is not defined as a timestamp, is not correct. Then there is a lot of other pre-processing checks that you can apply to clean your data. And then that goes and sits in your layer called silver layer. And from there, you apply the logic, the business logic. I'm calculating monthly active user metric. What's the definition of MAU? Let's conform to that definition and now calculate that MAU metric across all the products of the company, and then let's go and report it to the Wall Street. So because it's an aggregated data set, it can then go and sit into your gold layer, which is a certified layer, aggregated data sets, ready for analytical purposes and reporting. So there's a lot of advantages of implementing medallion architecture in an organization. Even if the data engineering teams are decentralized, you could still implement that in your lakehouse. And then once that is created, all your data sets, which are coming from different sources, conforms to the business definition layer and sits in a medallion architecture. Now you're ready to go and report to vertical teams, and they can serve their data needs. So that's how we solved it in Atlassian as well as in Unity. There's no easy documentation. Okay, a lot of time my data engineers come to me and say, I don't have time to document. Do you want me to document the data pipeline, or do you want me to derive the insights out of my data pipeline? And I'm always rushed to say, oh no, please figure out the insights, right? Because that's important for the business. With AI, can we now integrate some open source libraries from AI world, which can do automatic documentation of my pipeline? We are exploring this. Data contracts, schema management, huge challenge for the enterprise companies. Something changed in the Salesforce system, and it doesn't automatically reflect in your pipeline. How can we build or do? We use Data Hub, I believe, from LinkedIn, and to manage the schemas, and that's you will get notified of what changes happened upstreams, and you can manage that through incident management and some quality controls. So data contracts in data ops, it all falls under one category, if you will. And it allows you to write some quality checks on the data sets. And if you have integration with Slack or PagerDuty or whatnot, you can have an incident management as well going on over there. And then we integrated Superset and Redash, which are like open source visualization tools. And once your medallion architecture is set, your gold layer aggregated data sets are ready, you can now share the insights into Superset or Redash. So those are kind of like some solutions to the uneasy, I like to call them uneasy problems of modern data stack. And these are some solutions that you could apply. And now with the a lot of talk on the AI and the data, I'm reading a lot of interesting articles that even I've read the Hype Cycle 2024 from Gartner, and it talks a lot about like there is a boom coming up with a lot of AI and data engineering opportunities. We have seen the era of just AI becoming popular for app development, but then there is also how can you basically build your AI apps which are dependent on data, right? So how can we bring data and AI together to now build autonomous data pipelines? So good area to explore. I'm working on exploring that. If you want to talk about that, reach out to me. Okay. So I'll take a pause here. I think, Ro, I'm talking a lot. I want to quickly check if there are any questions for me so far.
So I want to talk about all this stuff. This is on my rewatch list because there's already so much. There hasn't been a question. If someone has a question, I'm just scrolling really quick in case I missed something. I'm just going to read some of the comments. This is such an insightful talk.
Thank you.
Oh my, this is hitting where it hurts. Great talk. This slide is spot on. Truth. One person, when you were talking about the problems, so it's everywhere. LOL. The uneasy modern data stack, right? Yeah, this is super interesting. Super interesting. So no specific questions. But yeah, go ahead. This is awesome. Awesome.
Awesome. Thank you, guys. All right. So let's quickly take a look at the Atlassian use case study. Remember in my intro, I said that the key takeaway for me from the analysis I did is like, no matter the team size, still an average data engineer in any organization, I could say that spends about 44% of their time in building and maintaining the data pipelines. And it cost me $520K per year. Now, I'm not exaggerating this number. There's a link to this analysis. You can read it. And how did we come up with the conclusion of like 520K per year? Now, this includes data engineering compensation, obviously, their bonuses, everything, their comp package, plus all the compute, storage, Google Cloud services that this particular engineer is using on a day-to-day basis, the pipelines that this engineer is managing. It could be an engineer or a group of engineers, but on an average, it costs you about that much. So my goal was, how can I reduce this? Not just in enterprises, yeah, but in general, what are certain thought process? What are the challenges with modern data stack? And now looking up to next gen data stack, how can we solve for these challenges, right? So I'll give you an example. In Atlassian, one of the key things that my engineering teams worked on is for the very first time, Atlassian had to report MAU, monthly active user, MAU metric to Wall Street. And this is like the very first time, I'm talking about a few years back, when Atlassian has to report this number. You guys know, right? Like your stock price, your financials are dependent on this kind of a metric. It's a pretty crucial metric for any enterprise public company. So we have to report this for the very first time. And God, it was a nightmare. Why? You might question, it's just one metric. You get the numbers, you define your what is a MAU definition, you get the numbers from different sources, and then boom, you're ready, deduplicate the number, and you're ready to go and report. It's not that easy. And why it's not that easy? Because first of all, in Atlassian, there are so many tools out there, right? Jira, Confluence, you have Trello, you have, and Atlassian is big in acquiring so many small startup companies. But the good thing is they acquire every company by taking data decisions. So we played a very, very crucial role, not just for reporting MAU, but also very strategic decisions of Atlassian were made which company to acquire based on data decisions. So I used to work very closely with Scott Farquhar and Mike, who are the CEOs, co-CEOs of the company. And I was very fascinated by them. Two things I learned from them is like the PLG mindset, like product-led growth. There was no sales team in Atlassian, and everything was data-driven. So I thoroughly enjoyed my time there. So coming back to the topic, time to build MAU data pipeline, it took me about 6 to 8 data engineers per year. Think about 10 to 12 months to build MAU master data pipeline for Atlassian. About 6 to 8 data engineers, 8 to 10 months. And the reason for that is so many different product teams, each has a different definition of MAU. Confluence has a different definition of defining MAU metric. Jira has a different definition. And they have, data duplication happening everywhere. In the lake house, the data from all these products are coming from the producers. And now their job is to pick and choose only Jira data, only Confluence data, and derive and calculate the insights MAU number and report it to their general manager. And this general manager job is to somehow report those numbers to CFO. And now CFO is dependent on my team. Hey, Natasha, how would you aggregate these numbers across all these products so that I can report one consistent number to Wall Street? Work with investor relations team. It's your headache, not mine. So that's what it took me. Why? Because we were dealt with so many different tech stacks, data tech stacks. So many different organizations have different way of reporting their numbers. There is no standardization built in the pipeline. The data is getting duplicated everywhere. And data engineers are always competing with the noisy neighbor problem. I'm sure you guys have heard the term noisy neighbor. The noisy neighbor problem is I'm fighting for the resources. I'm ready to do my check-in in the production GitHub repository or code, right? But I'm stuck because I'm waiting for some other data engineer to finish off their CI/CD setup and PR review everything before I could do my check-in. So weeks and weeks are gone before a data engineer can make a very simple slight change in the data pipeline. And that was annoying to them. So what my data engineering team did at Atlassian, few of the engineers came with an idea that, hey, Natasha, I would love to avoid this noisy neighbor problem and download some open source tools onto my laptop, create an integration layer, and then quickly build my pipeline structure on desktop itself so that I can avoid the noisy neighbor problem. What they actually did, they created an integration layer between open source software, as we talked about, like Airflow, dbt, or whatnot, and then the pipeline structure was created. They weren't testing anything with the data because obviously in an enterprise, you can't have access to the data locally. But the definition of the pipeline and the automatic DAG generation through Airflow was happening on the laptop itself. And once they are ready to deploy that pipeline in any cloud, like it could be deployed in Google Cloud, Azure, or whatever cloud your company is using, you should just deploy it easily over there. And the entire GitHub setup that you have on your local can go and sit in the cloud environment so that you don't have to do the rework. You could use Global Secrets Manager, Terraform templates, Pulumini templates to basically manage those deployments in cloud. So that was one of the key interesting things I said over there. Developer productivity improved drastically because of this, because now 44% time, as I said, it should help if I'm enabling the build of data pipelines, the structure of data pipelines locally. You can push it into cloud whenever you are ready and test it with the production's grade data. Cost savings, because now I'm not dealing with the infrastructure cloud cost. I'm just managing a Kubernetes environment at the back, Docker environment at the back. It's a containerized approach. So now I'm able to basically install different open source software on my machine, and I'm able to test a build of end-to-end data pipelines locally, right? So it's a huge cost savings, and a lot of pipelines can be built in a matter of minutes because the integration is already pre-built, right? It improved the confidence and trust in our business reporting as well, because if this is a case which we did in Atlassian and Unity, I believe both, which is an implementation of medallion architecture. Once you have medallion architecture, I can almost guarantee you there will be less hassle of data duplication. So definitely double check, go and read about modern medallion architecture and how can you apply those standards in your lakehouse so that there is a consistent way of reporting, consistent way of pushing the data for your ML models so that it can run the business as well. Yeah, so these are some case studies there. And it leads me to the concept of data products. Like, we have heard there are product companies, either it's a system-based application, a product-based application, or a product company in itself. Why not have data products? What is a data product? A data product is nothing but it consists of multiple data pipelines put together in a workflow. It could be called as a one data product. Pick any project. You're working on a MAU project, MAU pipelines. It might consist of 10 different pipelines together, but once you deploy it in production, automate the entire pipeline, implemented the medallion architecture, you're ready to call that as a data product. So the concept that, it's quite powerful. Try to implement it in your organizations if you can. but it's nothing but automated way of generating data pipelines, putting them together, and call that as like a data product. What could be the pillars of your those data products? You could enable the local end-to-end data pipeline development, as I talked about. You can deploy those data products in cloud, and then once it's deployed in cloud, you could actually put a conversational layer. And this is something where I'm investigating and putting my heart and soul right now. Happy to talk about it on how I'm planning to do it. But the power of like generative AI to kind of like have a conversational, if I'm a data engineer, and I'll walk you through like what does that conversational experience look like to build an automated data pipeline. I'm not going to bore you guys with the more technical stuff. Happy to share the slides if you're interested, but this is just the backend architecture, which is a service-based architecture for your pipeline, for your infrastructure, for the development of like, different tool integrations and whatnot. And this kind of like a backend architecture, which will help you achieve that tool integration that I talked about. Okay, so let's talk a little bit about AI and how I'm envisioning the future, and how AI can help the data engineers, build data pipelines with ease. Oftentimes, I get this question a lot from data engineers that, hey, Natasha, what are your views on AI data engineer? Is it going to take away my role if AI can build a data pipeline for me? And my answer is absolutely no, it cannot. It is going to, if anything, it's going to make your life a lot more efficient and productive. And I can show you exactly how. So this could be the tech stack from the AI perspective for the conversational experience on the data pipeline standardization. It's kind of like code gen. AI can generate the code for you to apply the quick standards, different stages of the pipeline from ingest, transform to load. It could help you as a pair programmer. It could do a lot of data ops for you, which is generate automated test plans. You can highlight the code. It's cursor.ai. If you have not seen, watch them. It's an open source. You can integrate it in your pipelines. And the moment you put the cursor on your pipeline code, it can generate an automated test cases for you, unit test cases for you, right? Which could figure out a lot of other different things from the data ops perspective. It can figure out your cost analysis, the compute cost and whatnot. Very, very helpful from that perspective. And it can, as I talked about, generate some docs, pipeline documentation for you as well. So some of the product design features, I mean, this is my vision. I would like to have it would be great to give a product in the hands of data engineers, which has a unified IDE kind of like environment. It's integrated all in one environment for data pipeline development, for your code and data management, and for your AI-driven assistance, which will automatically do version controls for you. Many pipeline checks and balances happens on a day-to-day basis. How could you implement built-in version control for your easy code check-ins and tracking of the commits? Think of I talked about different tasks, right, behind the scenes. And some core data engineering principles are quality, ingestion, transformation, lineage, and all that, right? Think of like having AI agentic architecture behind the scenes. And what these AI agents are doing behind is like, one agent is only trained for doing data discovery. One agent is only trained for quality. One is for just transformation, for lineage, for code suggestions and code reviews or whatnot, right? But it's an agentic architecture where all these agents are talking to each other. And then on top of it, you have prompt engineering. And based on the questions and the context that the LLM has, it can now have, think of it as a state machine, which is, at the end of the day, agents are doing the work based on the context which is given to the model, and it's responding. But how is it going to help a data engineer? We are going to talk about that in the next slide. So it can help with smart SQL writing, and a lot of code generation is possible as well. I think I didn't add that slide in here. But let me give you a little bit of a context on how and what could be the workflow for AI data engineer. So imagine I'm a data engineer working in an organization, and my company has already integrated some chatbot as an AI assistant, and I have integrated it in my developer environment, and now I'm building a pipeline. But the task I have given is from an analyst: calculate the sales orders for the top 5 selling products of your company. That's the task which is given to me as a data engineer. Now, the first thing, if I'm new, and even if I'm not new, the first thing I would like to do in order to generate a sales order DAG is, where are the tables? How can I do data discovery? Where is my customer orders and sales information? Because I need these 3 tables in order to build my sales orders pipeline, right? The first thing is a data discovery. You can ask AI agent, hey, where are these 3 tables? If the agent has access to your metadata repository, sure, it could help you find and locate where those tables are. Once you have found them, you can ask a question: are they certified for me to use in a production pipeline? Because that's the next check a data pipeline or data engineer is going to do. Am I allowed to use these data sets? Do I have access to these data sets? You can ask that question too. Okay. Next step. Okay, I know how to write a SQL. I have a business logic. I'm going to join these tables and create an aggregate for the top sales orders DAG. Okay, either you can write your own SQL, get some assistance from AI to optimize your SQL queries. It can generate the code for you. It can also do the code review for you, PR review for you. The noisy neighbor problem is gone. It's basically your pair programmer assisting you at every single step of writing your data pipeline, from data discovery to adding quality checks to basically doing code management, PR reviews, and whatnot. So that's how I envision the power of like AI and data engineering coming together. I'm happy to go deep dive into what does this really mean and how can you implement it in your enterprise with the power of open source and different AI libraries out there. A lot of enterprise companies are going to give a pushback today. Oh no, we can't install OpenAI. We can't install Anthropic because of security and privacy concerns. Oh, sure, you're going to get a lot of that, right? How to bypass that, how to basically create something which will still enable the AI and data to come together is something I'm happy to talk about in more details. I thought I added those slides, but maybe I removed it. Sorry about that. Now, value add to the users to everything that we talked about so far, and then I'm going to stop talking. We'll do a quick chime check after that, and I'll be happy to take more questions. But if you're able to build those integrations, leverage open source technologies, there's a lot of value add to the engineers and the teams. The user experience is interesting. You're not bombarded with heavy looking UI tools like Fivetran or Calibras of the world, where integrating those tools into your current tech stack becomes a problem. Now you have a single interface where you could build your data pipelines very easily. It's like a command line interface, and smooth integration is there with all those open source tools. Developer productivity, you have faster feedback loops now with local development, and your DAG is getting generated on your local machine, right? Whenever you're ready to push it to test it against data, you push it to any cloud. It solves your noisy neighbor problems. Then you can have some inbuilt transformation patterns. We talked about standardization. We talked about some pre-checks and quality checks. All of that is great to have is great to have or implemented as part of Medallion architecture. So that all helps developer productivity, seamless cloud deployment. You can deploy to Google Cloud using Terraform, Pulumi templates, GitHub, GitLab, Bitbucket, whichever choice of development tools that you have. And then, data observability can be implemented using the runtime metadata concepts. And you could potentially build an infrastructure for metrics collections for enhancing your data ops reporting. And then it could give you some insights into cost as well. And hence, overall, if you see, there is a lot of trust that gets generated if you implement this kind of an architecture. All right, that's about it. Let's check on the time and see how we are doing with the questions.
We have many questions, which is good. And we've got about 10 minutes. I think we can go over because the next meeting is lunch and I don't need to eat. All right, we can go. So if you're good, I want to be respectful of your time. If you're good to hang out and answer questions, if we go over
Yeah,
time,
yeah. Let's do it.
I got the sense that you would.
Yeah.
So
Okay.
let me scroll. I'm just going to go down the list. And so if you haven't asked a question, there's still time. Drop them in the comments and we'll go through them. So you sort of touched on a couple of these. There's one said, so I'm going to combine these two. One was, I'm keeping a close eye on AI generated docs on pipelines. Do you have any suggestions?
Yeah, that's a good one. I think what I would recommend for that is there are some, and I don't know on top of my head like which libraries OpenAI provides, but if your company or your enterprise allows you to have the lowest or the minimal, like the OpenAI, which is free version of OpenAI installed, it could be installed on your local desktop too. And if there is a metadata document which your company has, which is a data definition, all the different schemas are defined. I take one table and the definition of like columns, each and every column is defined over there. And if you are then giving an access to the code repository where your actual data pipeline code is sitting, now your LLM has access to the code repository where all the DBT models are built, and it has access to the metadata and the definition doc. As and when you're building the pipelines, it could potentially generate and learn the logic and generate the document out of it for you. So it's something, as I said, explore. We are also exploring, and something where you could potentially just try with OpenAI.
Cool. Switching topics. If people don't like or aren't willing to take ownership, do data contracts help?
Can you repeat that question? Data contracts help where?
In the event where you don't have buy-in, like your people aren't taking ownership.
Yes, yes, that definitely can help, which is what, automated change management, schema management, the easiest way possible. If you don't want to use any open source tool, check out Data Hub. If you don't want to use open source tools or any of the tool, you can still achieve change management and schema management. The worst thing, the easiest thing you could do is fail your pipeline. Get notified anytime the change has happened. What kind of changes we are talking about? The column name field, how often the schema changes. It doesn't change that often, but it can be changing in Salesforce, it can be changing in any application or whatnot. If you have a way to kind of like track those definitions through the metadata and runtime metadata stats, you could potentially identify that there is a change coming in my system. I don't know how to manage it for now. I'm just going to fail the pipeline and inform the downstream teams that the pipeline is failed today because we noticed a pipeline change upstream. So the schema management, a lot of time enterprises do it manually. That's the least they can do. But then there are many other open source tools which you can use. We have tried Data Hub.
Cool. So I'm going to read a comment. Do you want to stop sharing your screen?
Oops, sorry. Yes.
Go for it. It says, love the presentation.
Thank
Some
you.
of the pain points you touched really resonated with me, and I'll second that. There was, yes, you hit it. You hit us where it hurts. So you've already talked about AI, kind of AI apps in general. This question was asking about your thoughts, but then gave the example of Replit. Do you have any thoughts on Replit specifically?
Replit. I think Replit is mainly for software development. You could potentially build something similar to Replit for data engineering when it comes to AI. So I'll stop there, but
Okay.
that's my initial quick thought on that. It's code generation. So, but in the software world.
So next question, with the open source tech stack for data pipelines, how's the infrastructure set up? Do you integrate into cloud services or manage everything with Docker, Kubernetes?
Latter. Mainly, if you can have a containerized approach, use Kubernetes. Some of the tools can be installed in Docker containers and Docker images as well. But change control, everything, you need to keep up with the open source community. That's pain, but it is possible. From the infrastructure perspective, if you are an enterprise and you are already using dbt, the good thing is it should just seamlessly integrate or migrate, because dbt is open source. If you're using dbt on BigQuery, dbt on Snowflake, and say, for example, dbt on BigQuery, you already have the dbt models which are built in your cloud, in your projects, BigQuery projects. You could use dbt locally, and when you're ready to push that pipeline infrastructure in cloud, it should just work, because Google provide Kubernetes too. All you have to do is some sort of configuration and settings behind the scenes, and go and put in your containers what kind of version of Airflow you are using, what kind of version of dbt you are using, and generate the DAG once, and then it should work from there on.
That's very cool. Sean Ainsworth has the next question, but it's super long, and it's my question too. I'm going to say that because that's going to be, I can already tell it's going to be a conversation.
Okay.
And there's some smaller ones I'm going to skip to. Is generating metadata primarily a manual effort?
A lot of time I have seen companies do that as a manual effort. It shouldn't be. You should have a way to basically the easiest way, and especially in IT organizations, there are a lot of big heavy tools out there which you can use to generate your metadata and cataloging information. There are companies which are built on it. If you are part of an IT organization, sure, you can go with those tools. It makes sense because you are generalizing it for the enterprise. But if you sit in a business team, they often create it in an Excel. They often create it in a document by defining these metadata structures, metadata definitions, or whatnot. You could potentially create a software which is capturing the runtime stats, runtime metadata, as and when you're building your pipelines, as and when you're actually using the schema. As I said, we use Data Hub. We relied on that. Pretty cool software built by LinkedIn, open source. Check out and see if it is helpful. But it doesn't have to be a manual effort. You could use open source tools out there to both for collecting runtime metadata stats as well as generating the metadata.
Would love to hear more info on how to get around API integration restrictions to connect data sources.
There's no easy answer to that. It depends on your enterprise, but the way to get around it is use global secrets managers. So Terraform or HashiCorp provided that. I think we use that in Atlassian or Unity. I don't remember. But as long as you're managing your secrets and you are enabling, your IT has allowed, your SRE teams have allowed you to get access to the APIs. It's a very specific enterprise thing, but a lot of time you can get around it by telling your IT teams that, hey, we are managing the secrets, we understand the changes, this is what we are going to be bringing in. Always bring it in your test or a UAT kind of an environment rather than the prod environment. Do good quality checks and see what kind of data you want to bring in first, and then push it to production. But yeah, it's a very specific enterprise thing.
And then here's Sean's question, which there's multiple parts. I'm going to read them in parts. What are the best practices for implementing a robust silver layer in a medallion architecture? And then he follows up. He says, particularly concerning data modeling, UUID usage, and handling complex business scenarios. And then he gives an example. For instance, how can we design the silver layer to maintain historical accuracy while reflecting organizational changes, such as when a brand is sold to a new company?
Wow.
So there's a lot to unpack there, right? Isn't that a great question?
It's an awesome question, a very loaded one. Let's break it
Yes.
down.
Hmm.
Let's try and break it down. So first of all, yes, the whole identity management with UUID, it's always a challenge, and it's a very complicated problem to solve across the enterprises. But having said that, there is a difference between how MDMs are implemented and how the unique identifiers on the business side are maintained. So let's go back to the first half of the question, which is medallion architecture. When the data lands in the raw layer, it doesn't even have sometimes the files, data coming from APIs, doesn't even have a header file. It's a JSON format or whatnot. The very first thing the medallion architecture you could do is to convert it into a structure, a table looking like a structure, a JSON conversion to a table looking like structure. You could do it automatically through programming behind the scenes, or you can do it manually. I have seen data engineers writing Python scripts, Scala code, or whatnot to do the conversion from JSON to a tabular format. It can be done automatically. Then there is, once the data is in a structured format, which is the raw layer, depending on the schema and the metadata that is coming into the raw bronze layer, you could then apply pre-processed checks. And that pre-processed checks is what I called as like a part of standardization of your data pipelines. And these checks can be nulls. I want to basically remove all sort of dirty data, the data type field, the timestamp. I mean, a lot of other checks which doesn't come to my mind right now, but there are 5 or 6 different pre-checks depending upon the schema of the data which is coming, which you can automatically apply to the data which is coming in. And that can go and sit in your silver layer. There is no business logic yet on the silver layer. There is just some pre-processing checks. And after that is done, most of the times, if you are building a pipeline and the business logic is given to you, certain good quality checks which are often helpful to be applied automatically as a standardization layer is like the variation checks. So for example, a metric, you are calculating a metric. The metric shouldn't deflect from, I'm only expecting 2 million rows on a daily basis for this particular data set. But suddenly I got 10 million rows. Suddenly I got 0 rows. I got no
Hmm.
data, nothing. It's an anomaly. You could put those kind of checks as well. I expect my data, business logic, my revenue targets to be between 1 million to 2 million. But suddenly my revenue targets are looking like 0. My pipeline is calculating them as 500,000. Anomaly check. Fail the pipeline, notify the downstream teams. You could do Slack integration. I have seen teams doing Slack integrations to notify. You could do PagerDuty or whatnot, right? So all of that can be implemented as part of medallion architecture. When you read through the principles of medallion architecture, the small nitty-gritty details you can apply from your side depending upon what your use case scenarios are, what your business requirements are. And that is what I called it as quality checks within the pipeline. You could have so many different quality tools, which are heavy UI tools, but they are only good in doing quality, but it's outside of your data pipeline. Are you interested in? And that is good. But again, to me, that's an IT problem. If I'm using an application heavily and I need to report something to my business and it's a CIO's job, I could use one quality tool on top of that application and I'm done. But if I'm reporting into business, the quality change, the rules can change, whatnot. So embedding them as part of medallion architecture is very, very crucial. Still, silver layer. From here, once the pre-checks, and I call them as pre-checks and post-checks, once that is done, now you're ready to apply the business logic into the gold layer. And once you apply the business logic there, it could be, you know, a placeholder where an engineer can go and change the logic. And then once the data set is generated, you push it into the gold layer. And you need to create that structure. See, medallion architecture is all about structuring your data in such a way that everything is conforming to the standards that you have applied. Now, the standards could be, I have a business definition model. you can use a metadata tool for that, or you could, define it manually too, which is the definition of account ID. This UUID definition is associated internally with customer ID. When I see a UUID coming in, I actually mean a customer ID. So what is the definition of a customer ID? The moment I see UUID coming in, is it conforming to the customer ID definition or not? You can have that check. And that's what is, I call it as conforming to the business definition model. Predefine your business definition model, check the data sources coming in through APIs or applications or whatnot, conform to that business definition model, layer it into the silver and gold layer, and boom, you should have a lot of benefits by just doing that.
So I think as a follow-up, it's not factually correct to say that DBT is positioning itself to own the silver layer, because you use DBT in all three. But I feel like a lot of DBT's like practices that they put out, the knowledge that they put out, when I read best practices for implementing a silver layer, I'd probably read up what DBT is publishing. What do you think on that?
Yeah, DBT is a great tool. We heavily rely on that. From They have their own pre-checks and post-checks, which
Mm-hmm.
could be added as a task in your Airflow workflow. So either you can use that, or you could use Soda Core, which is also a templatized version of adding your pre-checks or quality checks. It's again open source, right? So it depends. If you're writing the data models, everything is structured in your DBT in silver layer, gold layer. It really again depends on how a data engineer wants to structure it. I had some key architects, data architects in the team define that standards, define that principles, which every data engineering team has to follow. And that's another way of like calling it as a success. But yeah, you could use DBT for the checks too.
We've got, how are you on time? We're about 7 minutes over.
I know.
You good for a couple more?
Sure, I could try. Yeah, you guys are asking great questions. How
What?
many people do we have? Wow, we have a lot of.
So there's 40 people hanging,
Wow.
like pretty much. We had some fall, like people had to go eat or just right. We went over, right. The mind
Yeah,
can only absorb what the seat can endure. But we've got people hanging out listening.
yeah, good, good. I'm glad
What
that this is helpful. Mhm.
what open source tools are you using for lineage and data contracts?
Data Hub, as I said, Lineage, nothing. Um,
You can get,
Mainly,
I
mhm.
mean, lineage you can do in DBT, unless I'm
You,
misunderstanding the
but
question.
yeah, we could potentially do that. That's what I said. Like, we by default, like, there is no tool explicitly for lineage that we have integrated into the tech stack.
Okay.
What we have mostly experimented with is Airbyte, DBT, Airflow, Soda, Superset, and Redash. But for contracts, again, you could program it, the schema changes which are happening, because it's very difficult to use tools like Atlan or Monte Carlos of the world. They are great tools in my opinion, but it comes with very, very heavy price. It's not easy to integrate them in your current tech stack. um, if I'm able to get away with the integration of tools like Airflow, DBT, Airbyte, Soda Core, Superset, Redash, and if I have programming done for capturing my runtime metadata stats, I have the concept of data sets, which DBT is publishing very, very soon. If I follow those standards, there are small nitty-gritty details that you need to follow as a hardcore modern data stack data engineer. I think you can overcome the challenges of modern data stack with just following those principles. It depends on what kind of tools you're using. If you're a DBT user, I'm a big fan of DBT. I met the CEO multiple times, and it's great. It has a lot of potential in my opinion.
There's so much that you're saying. I'm going to get a transcript of this and throw it into Perplexity, because I'm not the only one that loves it, but that's awesome.
Thank you.
Um,
Thank you so
could
much.
you share more insights on industry specific Gen AI integrations? in the data stack?
Who I would share with? Sorry, I didn't catch the question.
Just what are some other Gen AI tools that are integrating into the data stack that are on your radar?
There are not necessarily Gen AI tools which you can integrate. I'm a big fan of having um, train either OpenAI or Anthropic on the principles of data engineering because they
Mm-hmm.
are already doing a lot of great things. I think an OpenAI can generate a DAG for you, for example, an Airflow DAG.
Mm-hmm.
It can generate the code for you, but is it trained on how exactly to do that? No. Can you train it? Yes. So I would say if you want to really try it out, just do OpenAI, train, give access to the code repository where you have DBT models or DBT, data models checked in, like which is your code repository for your data pipelines, and give access to the metadata information as much as you can. It doesn't matter, even if it is written in like documents or in an Excel sheet,
Mm-hmm.
define some structure to it and give that as an input. Try to do the setup and train it, then try asking questions and see what does it do. You would be surprised, right? But a lot of fine tuning is important, especially when it comes to data engineering principles. So it doesn't really matter which Gen AI apps or tools out there, but I'm sure there are many startup companies which are coming and trying to evolve in this space. But if you truly look at the foundation for these companies, they are using a lot of open source AI models which are out there. So the key is in fine tuning them with key data engineering principles, and that's where you really need the expertise on.
So I'll read some of the final comments. Thank you, Natasha. Wonderful talk.
Thank you so much for having me. I really loved it.
This is one of the most comprehensive sessions about data stack with lots of actionable insights. Thank you.
Thank you very much.
Super informative session. I'm quite surprised and relieved, and also relieved that actually these problems don't apply only to me. Thank you for this, for the insightful solutions. Yeah, thanks for answering my question. Great questions, hitting all the right spots. And yeah, thank you so much. Thank you so much. This has been great.
No, it's amazing to be here. Oh my God, I see tons and tons of questions. Sorry we couldn't get to all of your questions.
We got to most of them. Most of them.
Perfect.
Very cool.
Perfect. But reach out to me. Feel free to reach out to me on LinkedIn. I'll share my email address as well. Happy to answer and connect with you guys on LinkedIn for a coffee chat if needed. But thank you for having me. It was a pleasure. And thanks for the wonderful questions. Awesome audience. Take care, everyone.
Thank you. Take care.
Thank you. I don't have to stop broadcast now. No.